Okay, so the next set of videos is obviously in the new booklet. So you should have your new booklet. This is the front page. It's the industrial and modern period. So you would have just finished the Middle Ages and the Renaissance. We are now on the new booklet, which is the time frame. So the first what we're looking at is the 1700 to 1900, which is the industrial era. So to kind of carry on with our theme of the kind of previous videos here, we're looking at obviously things that have changed or stayed the same in medicine, and how things have developed. And you'll see in the industrial era, you've got a something that's incredibly significant, which is what we are learning in the next lesson. But before we get to that, we are today looking at Edward Jenner. So obviously, to understand the kind of context of it, we're looking at the industrial age. You don't need to know specifics, but when we're thinking about the industrial age, 1700 to 1900, we're thinking about this is a time in which there's this change from, in the cities especially, mostly, you see the development of factories, we see increase in production, we see machinery, we see migration from the countryside and urbanization. But also with that, when you have more people moving into the city, that obviously might lead to, that's going to lead to overcrowdedness, which might lead to, and it does lead to, conditions that aren't particularly great, whether that be in the work or in the home. So cramped conditions. You might see with more people come more things, so stuff, that might affect, and in our case, this is what we're thinking about, the idea of sanitation, the idea of clean streets. Okay, so just to give you the kind of context of what the industrial period actually was. Now, what we are looking at today isn't actually in the city. We're looking at an individual who's from the countryside, and we are looking at Edward Jenner. Now, this person on the screen right now is a child who has a specific disease. And Edward Jenner ends up being someone who, while he doesn't really know how, he ends up creating a vaccination. So he doesn't understand the science. He's not so much focused on the science behind it. It's not as if he's developed a kind of formula for vaccinations, but he's able to design the very first, very first vaccination for the disease smallpox. Now, the smallpox was a disease that was highly dangerous, and it swept through Europe. By 1980, it was declared eradicated from the world. So when we think about our Simples criteria, Edward Jenner, one of his big significance is that he's able to eradicate a disease, smallpox. Smallpox was a big killer, and it really only exists now in laboratories to kind of study. Now, our question today, what we're looking at, is we are looking to see, why is Edward Jenner so important to medicine? Now, kind of given you the information there, but we really need to understand his story and why he's so important. So the first sort of thing that you're doing now, a lot of this, oops, that's the wrong one. A lot of the next 2-3 activities, quite similar formats, just because you have a lot of context that you need to know, knowledge you need to know, and the more important part is being able to use that information for the second half of these lessons. So first of all, we're looking at, why is Edward Jenner important to medicine? So in here you can write down cow but doesn't know how, and that's gonna make more sense to you in a second. And the whole concept of it is he uses a cow, or cowpox, to eradicate the disease smallpox, but he doesn't really know how. It's like I said, it's not like a set formula that you can apply to different vaccinations. Now, what you have to do first of all is to use the words. So I'd prefer that you don't use the words that are up here and use the ones in the blue box on the right there. And I want you to literally read through the story of, read through his story, so starting from the left on to the right, fill it in, and then I want you to highlight any problems or negatives with inoculation. So there's something called inoculation and there's something called vaccination. I want you to figure that out and answer the two questions. And then examples of how Jenna used the scientific method. So again, thinking back to when we did this with Harvey, what do you do when you're doing a practical? You're observing, you're recording, you're experimenting, you might repeat it, you should repeat it, you might spread your discovery. Those are all examples, and I want you to pick out those specific examples. Now, when you look at Jenna, so I'm not going to give you all the kind of answers here, you should be able to see that he is a country doctor who finds out that there's a disease that is called cowpox, an animal disease, that actually ends up curing this human disease, smallpox. Now, there are two different examples of how to do this. So one is inoculation. Now, inoculation is a very, 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 very old type of treatment. And what it is, it's when they use, so it's this first one here, they developed a method of inoculation which involves spreading material from A and then figure out which one they're talking about, but taking a bit of a scab of an illness and putting it on an open wound. Now, the idea behind that is by putting a literal disease on an open wound, you are giving that person effectively that disease. You are igniting an immune response. Now, inoculation is using that same disease, okay? So in this case, it'd be using a little bit of smallpox and giving it to someone and really hoping that they're not going to die from that, okay? Because remember, you're putting in an infection into someone, so you're really going to be hoping that someone doesn't die from that. Now, that's essentially what inoculation is. Now, vaccination in this sense, so we're talking about in this particular story, the vaccination is using cowpox, so a strand of cowpox to put into someone so that it creates the same response that the body would do for smallpox. And therefore, if you were to have smallpox, because your body's already done it once when you had cowpox, and cowpox humans don't die from, your body would be able to do it a lot quicker, so you won't die from smallpox, is the theory. That's what vaccinations are. We all were given vaccinations as children for certain things because the whole idea is we're given a weakened strand of a disease so that our immune system responds to it. Now, the next time we get it, our immune system will respond to it faster, meaning our body will be better at dealing with it. It's why right now coronavirus is such a big deal and finding that vaccination, because people want to put in a weakened strand of something so the body works fast at dealing with it. So if they ever got real coronavirus, they'd be fine with it, is the idea. Obviously, it's a new thing, but that is the idea behind it. So that's really what you should be doing. Obviously, you need to think that what he essentially does is he uses cowpox on a child and then infects him with smallpox. There is a video link at the end of this PowerPoint that you can watch to kind of give you a summary there. But what he does there is really taking a risk and hoping that it works. And that's part of his scientific method. He does it with 23 different cases. He does publish it, so this is what you should be writing in question 3. He was observing a milkmaid, and he does it to this boy, James Phillip. Now, he's not accepted. His vaccination, while it was effective, and it was a big killer in Europe at the time, it was only in 1852 that it became compulsory. Okay, so before then it was just like, oh, you can go if you want, but not everyone went and did it. So what you're going to be doing in this next page here is you're thinking about why is vaccination using a weak strand safer than inoculation? Not using a weak strand, using the same disease, but a smaller version. Why is vaccination safer than inoculation? And what evidence is there that vaccination was effective? So where can you see that it was effective from the information that you would have just read? So just to give you some sort of examples here, those are the answers. Again, you can pause it and self-assess whether you've done that correctly. And then our next thing, what you need to do is you need to think about the limitations to Jenner's discovery. Why is it that this vaccination, so just to give you some extra knowledge there, vaccination comes from the word vaca. So I'm just going to write that here. Comes from the word vaca, which actually in Latin means cow. So you should be able to remember that this vaccination, this cowpox used for smallpox, is the first vaccination in the Western world for smallpox, okay? And you can also write down here that eradicates smallpox. Now, obviously, there are some serious limitations here. And here are your limitations. So you are given 4 categories. Stopping smallpox was not a new idea. There was much opposition, the impact of vaccination was delayed, and vaccination did not lead to other medical breakthroughs, which is why it's cow but doesn't know how. They just know how to do smallpox now. And I want you to read through it and just put a number on which category that would fall under. So if I was to just pick one over here, the Royal Society rejected his advice and others did so as he was from the country and was not a London doctor. So if I was to read through each one, I might put in, okay, well, that's number 2, because there was opposition. People didn't want to kind of go with his vaccination because he wasn't respected. He was a countryside doctor and not from the city. After you do that, I need you to read through the boxes and just fill it in. And then again, summarise what are the oppositions in the however box. The same activity that you would have done with Harvey and Vesalius. When you finish that, I would like you to attempt, so just practicing your judgment planning, think about this question. Vaccination against smallpox was a major breakthrough in the prevention of disease in Britain during the period 1700 to 1900. Now, you won't be able to complete this right now because he's the first person that we're learning about in the 1700s. But what you can do is make sure that you at least know why he can be seen as a breakthrough. So you can put some examples in there, and as we kind of go through the lessons, you can go back and fill this in. Here are just some vaccination acts that could be more further examples of why it was, why it was a breakthrough in prevention of disease. And you can argue that it's actually not, because it wasn't compulsory for a long time. And that is lesson 1. Now, if you feel like you want to kind of think about the story even further, so have a look at this source. Think about why people were opposed to the ideas of vaccination. So if you look at the image, you've got people who are animals. Now, I said to you that cowpox was a animal disease. It's a disease that only really happens in cows and different animals. So why would that be rejected? What would these people in this society think about injecting themselves with a disease that happens in animals? If you want to attempt the question, you can use the following in your answer, but like I said, you won't be able to complete that box because you'll only be able to complete the cow box section of it. And if you would like to watch a video on it, you can do so when, if you just write down in YouTube, Edward Jenner BBC, and a video will come up just kind of showing you his story, a little bit like the pathway that you would have done in the beginning. Thank you.